I need to be real with you guys. As much as I love TypeScript, it absolutely has its problems, in particular with performance. No, I'm not talking about the runtime performance, throwing it in Node or Bun or however else you're choosing to run it. I'm specifically talking about TypeScript performance, meaning the TypeScript language server in LSP. We have the Golang rewrite happening now, and I'm really excited for it, but there are problems that I and others are dealing with right now that should absolutely be fixable. In the bigger codebases I work in with tools like Zod and TRPC, I find myself just Command-Shift-Ping, typing res and pressing enter to restart the TypeScript server whenever I have problems, because it's so likely that it crashed or fell behind or just has problems because of the amount of inference it's doing to figure out the types for everything. I almost feel like I'm being punished for buying so heavily into TypeScript. It seemed like this problem was solvable, and I and a few others really wanted it solved. Alex, the creator of TRPC, and I decided to put our money where our mouths were and try to get this fixed once and for all. We reached out to an industry expert in TypeScript server performance to do an audit of TRPC to try and figure out what was wrong. The result of that investigation is something I never would have expected. A big change that just merged to TypeScript itself that is now available for everyone to use in the TypeScript beta. This has been a wild journey, and it's some of the best money I've ever spent, and I'm so thankful that a little bit of my time and cash could go towards something this cool. I can't wait to dive into all of this with you, as well as the other cool things changing in the TypeScript 5.9 beta, but none of this is going to make me money. In fact, it cost me money. So quick word from today's sponsor, and then we'll dive right in. Is your app actually secure? If you said yes, how sure are you? Can I spam it with requests? If you have an AI generation endpoint, can I just hit that a whole bunch and cost you a ton of money? Security is more important now than ever, especially if you're building AI apps where a request can cost dollars instead of hundreds of them costing cents. I've been hit hard with this with T3 chat, and I want to make sure you guys aren't either, and that's why today's sponsor is so exciting to me. I was actually an early investor in ArcJet, and it took them a while to build what they have today, and I'm so excited that they're now sponsoring me so I can tell you guys all about it. These guys really get security, and they really get developers and developer experience. Every other platform I've seen like this is a bunch of dashboards and configurations that are really far from your code, and that's why I just never really used them. Even things like CAPTCHAs tend to be as much dashboard configurations as part of your source, and it has driven me insane. I really wish ArcJet was ready when we started because it is perfect for what we do now. They support pretty much every web framework you'd want to use, vanilla Node.js, Bun, or things that are deeper like Next.js, SvelteKit, and even Nest.js, believe it or not. They have everything supported. So if you're an enterprise with Nest or you're a small startup with Next, you're good to go. You can set up a generic shield to protect from general attacks, but what's much more exciting are these sections here, like the rate limiting code. This is so good. You put in your key, you choose the characteristics that you want to use as identifiers for the rate limit, you then create a token bucket that has rules like how often it refills, how much it refills, and it's all just in the code. You don't have to do anything special. You would think that this is going to be slow because it has to go hit up their network. It doesn't. It has a WASM binding internally where it can verify the request, and if for some reason it's still not confident, that's when it will spit out and ask their service to check things, which makes it super fast, super cheap, and also super reliable. The bot protection is killer. If you have an endpoint where users can generate stuff with an LLM, you do not want bots to be able to hit that endpoint and generate a ton of stuff. It will cost you insane amounts of money. Take my word for it. We've been there. Have you ever seen a security product that's entire homepage is source code examples? Speaking of AI, they have a whole guide and blueprint for how to do tokenized refill rates. So if you want to make sure users don't generate too many tokens in a given window, that's covered too. I haven't seen any of these companies focus on this in particular. I might have to make the move myself. Secure your app today at soydev.link/arcjet. Going in from the start, here's the group chat where this all kind of happened. Alex had hit me up asking if I knew David well enough to make this intro. I did, and I was very excited about the opportunity. So I made a group chat where we could all start talking about what we can do to potentially fix the performance issues with the crazy nested TRPC routers. I should probably give some context on TRPC for those who aren't familiar first. It is the best way to do backend and frontend together in TypeScript. I'm at the point where if your backend and frontend are in TS, and you're not using TRPC, I'm questioning your decision-making process because it makes life so much better. It's also one of the bigger inspirations for Convex, if you're curious where their concepts for having this really good back and front end like linked together came from. TRPC was the originator of a lot of that. It was originally created as a demo by the guy who made Zod, Colin. Alex came in and took it over and has pushed the project super far. It was also the core of the T3 stack back when that was a thing I built and pushed much harder. Since then, T3 stack's become much more modular, generic term for different ways of building, and TRPC's gone crazy far itself. But why is this something that has performance issues? Well, first we should see what it does and how well it works for it. I'm going to grab a random TRPC function in our code base and look at how we use it. So here I have my use user info hook. This is the hook that tracks your user information on T3 chat. This hook is what gives you your name, your email, and all these other details for your account on T3 chat. So we have a use query call, which is just handstack React query, by the way, just traditional React query. We pass it this query options helper. This is the new way of doing TRPC that I really like. So we call use query with trpc.getCurrentUserInfo.query options. And this dumps all of the things that React query needs to fetch it, to cache it, to manage it, and do what it needs to. And this is front-end code, obviously. This is the React hook to use this thing. Watch what happens when I command click. It brings me to the procedure where it is defined in the backend. Tell me that's not the coolest thing ever, that the backend and front-end code are fully type safe back to front. And if we're consuming this hook other places, like, let's see where we're using it. We're using it here to show information about your account. We check is pro on data.tier. So let's say I don't include data.tier and I just comment this out. Notice that I haven't saved yet. My file is unsaved and we're still getting a type error here because it is true backend to front-end type safety. There is no code gen, there is no special tricks or hidden things like you normally have to deal with. I don't even have the code base running in dev right now. I just changed the code, and since it's full stack type safety, and they're all being consumed with inferred types, by the way, you don't have to define these types anywhere. That gives you a really good full stack experience where pass-through layers like this custom hook aren't where the error occurs because they're not where the error should occur. It should occur where you're consuming the data. This makes it way easier to detect bugs and where they actually affect things. And in a new AI era where your AI needs this type of feedback to know when it's making good or bad changes, it is a lifesaver. I have been so pumped with TRPC and how easy it is to attach your backend and your frontend with proper type-safe query logic, as well as mutations. Its core building block is the procedure. It's kind of like an endpoint, but you can do a lot more with it. You can create a custom procedure that is a private procedure, for example, that only works if you're authenticated. So if we go to the account services router, here they're all protected procedures because you need to be signed in for them to work. So this procedure will fail if you're not authed. And by the time the code runs, you know that the user has to be authed. So why am I bringing all of this up now? I wanted to give a brief overview so you can see how well TRPC uses TypeScript at depth. This is the TRPC router for T3 chat. You could think of this kind of like you would a GraphQL schema, where this is all of the things you can query for on the client. You can put a query just in the router directly like we do here for get current user info or get rate limit data. But then we have sub-routers for certain things, like billing is segmented into its own router, account services is, auth is, and our legacy router for a bunch of our old data fetching stuff is. These routers are collections of endpoints that are defined in their own box to make it more composable and easier to like isolate and separate. But it's your choice on if and how you do this. But it is very common that people will have a router that has a bunch of these sub-routers. And each of these sub-routers is defined the same way. You create a procedure, you give it an input, you give it a mutation. And all of this is type inference from the bottom to the top, where when we use billing router, we have this protected procedure named get billing portal. The input type is inferred through .input, and then the return type is referred based on the .mutation function's return value. So we have to do a lot of inference going up the chain. We have to infer the input in order to figure out what options is. We have to infer the return type in order to figure out what get billing portal returns. We have to infer this for all of the other values here. And then when we dump it here, we have to infer all of those parts as well, because there is no type definitions. One of my favorite things about TRPC is that when you look through a TRPC file like the one we're in right now, there isn't a single line of TypeScript. This is actually just vanilla JS. There are no type definitions anywhere in this file. This file uses type inference. So your input isn't typed, your input is validated. Here we're using valibot. Usually people use Zod, but you can use whatever at this point. The return doesn't have a type. I didn't do options : some stuff. I just put ops and it's inferred. This is, in my opinion, the right way to write TypeScript. And at the absolute least, you should be avoiding writing return types to the best of your ability, because TypeScript return types can clobber the types of the things that you're returning. I have a whole video about that from forever ago if you haven't already seen it. The reason I'm going through all of this right now is I want to emphasize the amount of inference that a tool like TRPC does. And since it's all inferred, The problem that occurs is when you make a change, everything has to be re-inferred from the bottom up. So if I change the return type here and I just comment out this tier in this return, all of the TRPC router's pieces have to be recomputed for that change. And this happens whenever any change occurs. It also happens with like an n times n type problem where every new endpoint requires a recheck for all of the endpoints. This results in bad performance for the TypeScript server. And it means your TypeScript compilation times will be worse than they should be. It means your editor performance will be worse than it should be. It means you'll be Command-Shift-Ping, restarting the TypeScript server a lot more than you should be. It's not great. They have made huge strides in TRPC performance, but it's still not where it should be, which is why Alex and I reached out to David, the creator of ArcType, to try and get it fixed. If you're not already familiar with David, you should be. His work is incredible. ArcType is the best performing validator by far. When I say validator, what I mean is a tool that checks a random blob of JSON and makes sure that the output is the right value. So if you have something like an endpoint or a form where users can submit data, you don't know if they're submitting it in the right shape. There are a lot of solutions for validating that blob to make sure it is the thing that the user says it is or that you're expecting it to be. The OG one that I used a lot back in the day was Yup. Zod came out and was much more TypeScript focused, which made it much stronger. And now we have tools like ArcType and Valibot as well that are even more performant and potentially even more capable solutions. The validator world's gotten a bit crazy. Schema validation is in a really good spot right now overall. And ArcType is one of the main reasons why it kind of drove the whole craft forward as a result of the work that has been done here by David and his other contributors. And it's also very clear from both his work in ArcType and more importantly, his work creating benchmarks for tools like ArcType, that his understanding of TypeScript server performance is unmatched. And that's why we reached out. We're going to do an analysis of how TRPC works in these big projects, in particular, why project references didn't seem to work for TRPC projects. If you're not familiar with project references, it's kind of a way to draw a line in your TypeScript code base saying, hey, this is its own separate subtree, cache the result, and if nothing changes within the subtree, just reuse that cached result. You don't have to recheck this piece if we change another piece over there. And it seemed like this should just help a ton. Like if I was to do a project reference for each of my routers in here, if I put one in for billing router, account services router, and auth router, none of these should be checked when I change something else over here. But that wasn't the case. We were seeing performance problems even with project references set up as far as we knew correctly. This nerd sniped David hard, and he went in trying to figure it out. He found a couple small things in TRPC that could be improved, but not too much. What I ended up finding instead were some weird cache behaviors for TypeScript itself. In particular, when we do these deeper nested mappings across large objects with chains, the cache kind of just broke. David then showed this to Andarist, one of the most legendary TypeScript contributors. It's actually kind of funny he doesn't work at Microsoft on TypeScript because he's almost certainly the most prolific contributor that isn't a Microsoft employee. He might even be within the most prolific contributors period at this point. It's kind of nuts how often Andarist is in here fixing stuff. And I swear on my life, half the time I'm checking PRs on TypeScript, it's things he did. He works hard to make these things better. So he also got nerd sniped by this and dove in and made 2 different PRs to potentially fix this. So let's look at these examples to see what exactly is wrong. Because as always, Andarist did a great write-up. Here we have a merge type. This is a generic merge type that will take 2 types and merge together their keys. So here we have P1 and P2, and we want these to become a new type that has P1 as number and P2 as number. And then we want to do the same here with P3, P4. You get the idea. And by here, it is broken. And by here, it is broken again. It's pretty funny that at a certain level of nesting, it just starts to fail. Not great. Here we even did a custom type to try and make it less bad. And it still starts failing relatively early because of the level of nesting in these checks and how the caching just kind of fails. You'll also notice that when I open this and run it with a given TypeScript version, it's rerunning the type checker. See how slow it's taking? Like it's still loading this code that should seemingly be quite simple, but nope, that took forever and it's still broken and is incorrect about the types for a bunch of these things. Not great. So what are we going to do about it? I dug into this, and what I found out is these types refer to the same base types. They are chained from them, and instantiate type repeats the work on them a lot. Bold, a lot. At least part of the problem is that get object type instantiation calls instantiate type types.alias arguments mapper to create part of its cache key. So it can't even check if the result is cached before it instantiates those. This problem compounds heavily in longer chains like this. That's the key here. Since it's using the instantiate type call as part of the key for hitting the cache, it's calling the check even just to see if it's in the cache. So there's no way to avoid the check. And the result is some really rough performance for these big code bases using tools like TRPC or Zod with a lot of these merges. They break aggressively. Looks like this has very positive impact on instantiation counts across the test suite. It surely trades some memory for it, though. It'd be interesting to see perf results for this and an extended test suite run. Edit. David here tested this in some TRPC-based repositories, and the check time got halved for them. The current version's also able to type check the 50-item deep chains, as it can be seen in the added long star tests. Those previously were only instantiable to certain depths, like 15 to 25. The last items in the chain were being instantiated really slow. Now those longer ones are all handled pretty fast. I didn't realize how big this PR was too. That's a huge change. Interesting. Is it because test results changed maybe? I haven't looked at the code. Yeah, it's largely changes to tests by the looks of it. A ton of test stuff changed. Makes sense. But the actual code change is relatively small here. 2,319 lines in, because the type checker file, like all of TypeScript is this one checker file that's gigantic. It's a very interesting way of building. So some code was changed on lines 2,319 to 2,322. Other code was changed in the 20,000 range. Very fun. So here we're defining the new active mapper cache. And then down here, we are checking for that map cache and using it if we have a cached value that is accurate based on the key that we're doing. Nice change, relatively simple. Caused a fight because every change to TypeScript does, as honestly it probably should. It's a very important project. Getting these things wrong is dangerous. But how are the performance wins? Here we're using @test by our friend David. @test is a really fun benchmark because it uses TypeScript itself to benchmark TypeScript. The way it does that is it increments a value in its type definition every time a mapping or a check occurs. So this number here is actually type safe. The performance check here is that when you write the code, it creates a type for the bench, and that type is the specific number of how many steps it went through. So the code itself effectively self-documents, because if you put a wrong number in here, it will type error and make you change it to the number of how many instantiations occurred, which is just so funny. That's how AT-test works. I have a whole video on it. It's so cool. This actually benchmarking TypeScript video that bombed when I did it is a deep dive on that benchmark and how it works. Highly recommend. I'll put the link in the description if you want to go check it out. So here we see this test did 59,000 instantiations. This one, just by adding one more value to this merge list, went from 59,000 to 177,000. One more value bumped it to 531,000. Pretty nuts how quickly these numbers ramp up. He didn't put the bench values for when he changed it there, sadly, and I'm too lazy to go rerun it myself. But what we do have here is when Andarist ran it in a TRPC-based repo. TypeScript 5.8 had 12,133,763 instantiations. This branch cut it down to 817K, almost in half, and it cut the check time in over half, with a slight bump to memory usage. Huge change. Part of this investigation was from him looking into Answer Overflow, the open source project by my friend Reese, which is unexpected and really cool to see, because this use mutation check was taking 2+ seconds to do type checking on, which was a really good candidate for them to use as an open source test to figure out where the performance problems were. Not a traditional benchmark, and certainly not a minimal repro. Really useful though. But then he went and created the minimal repros and did a bunch of benchmarking and is seeing massive performance improvements for things like cal.com, the open source Calendly alternative that is also really deep on TRPC. Funny enough, Hellsberg, the creator of TypeScript, hopped in here saying that this approach seemed hacky, but there was a good incentive to do it. I'm in the middle of JS exporting work for the TS Go code base. So it was, because again, TypeScript Go was really important. He was too distracted trying to get JSX working in it to check on this immediately. I love Hellsberg. His willingness to concede when he sees the numbers. So here he wasn't sure about the caching benefits being that great, but I see how it is much more dramatic in these micro benchmarks. So I agree that there's merit to the additional caching, but ideally I'd like us to target it at the expensive instantiation level instead of just caching all instantiations. Concerned that caches might not always be invalidated? Totally fair. Alex says he'll try and address it. I believe he did succeed in doing that. And then it all got merged. And again, the huge gap here is in the number of instantiations. These changes knock it down by 78% for times the type checker is actually generating these types and checking them. That's a huge change. And now when we're in the nightly build, you can see the type definitions keep working all the way down to 50. It finally works for this whole thing, which is kind of nuts. P51 fails because it doesn't exist. This should error because O2.shape shouldn't have P3 on it. 25 should have P25. Pretty cool that this all just works now. Like, how crazy is it that this TypeScript code that is totally valid would just break and run super slowly before, and now is totally fine and reasonable? Because as weird and esoteric as this might look, these types of merge type functions are essential to tools that we use every day, like, again, Zod and TRPC. I was really pumped about this. And as I mentioned, I want to make sure these people get paid for the work they do. So I threw $3,000 over to ArcType. And you know what? I'm going to pay Andaris a bit more too. I'm already giving him $50 a month, but this is a big deal. There we go. Paid him too. If these things benefit you, you should go pay the people who made them happen. The least you can do is support the maintainers that make this all possible. But as I mentioned before, this is not the only thing that changed in TypeScript 5.9. In fact, there's a really big improvement for the editor experience in the 5.9 release that I'm very excited about. It is still in beta, but I'm almost certainly going to go install the beta on my real code bases soon. And honestly, you should consider doing it too. It's not that sketchy. These betas get battle tested super hard by Microsoft. So using a TypeScript beta is totally fine.Avoid the nightlies. Those are sketchy, but use the beta. If you want to, at least. They're pretty good. Anyways, let's see what they improved. They updated the --init so that it's minimal now. --init is how you create your tsconfig file if you don't want to copy paste one from an existing code base or use another code base init tool that has one already. Cool, awesome. Nice to see them make it way simpler and more vanilla and commenting out things that you might want to add in yourself. I like that no unchecked index access is on by default. I still think this should have been the default in the language, but I understand why they had to do it differently because they added it later. Import defer is really cool. It lets you import a module without immediately executing it and its steps. So you can choose if/how to actually call the thing later on in the code. So if you have code like this, where we have some instantiation with side effects, a function, and then we export the value, this import defer means the code doesn't run until you actually try to hit things from that imported location. Very nice. New module mode for Node 20, cool to see. Summary description in DOM APIs. This is a very nice one. DOM APIs in TypeScript only linked to the MDN docs for the API. These links were useful, but they didn't provide a quick summary of what the API actually does. Thanks to a few changes from Adam Nagy here. Also, by the looks of it, not a Microsoft member. Funny enough, a Flutter dev too, but is a TypeScript contributor and made a really cool change here. Yeah, tool for generating DOM-related TypeScript and JavaScript library files. That's really cool, which is included with TypeScript releases as the types/web package. This is super cool. Good stuff. Believe it or not, the browser does have a MIDI API in it for doing music stuff. Now we get this little description. The MIDI output interface of the web MIDI API provides methods to add messages to the queue of an output device and to clear the queue of messages, available only in secure contexts. That is way more useful than what it used to be. If I select 582 and we hover over, we get available only in secure contexts in an MDN reference. That's a significant win. I know it seems small, but these little things are important, and they're a big part of the work that the TypeScript team puts in to make it a pleasant experience to use TypeScript. Not only that, this makes it more pleasant than JavaScript. How funny is it that these useful web standard things are better experiences in TS than JS because they integrate them into the language server better? Super nice. I know these things seem small, but they add up quick, and it's all these types of improvements that make TypeScript today better than TypeScript was last year. Speaking of which, probably the coolest change by far is the expandable hovers. I almost wanted to make this its own dedicated video because it's such a cool win, or at the very least hint at it at the start of this video. I forgot to. It is what it is. This is your reward for making it so far into the video, by the way. Speaking of which, if you made it this far and you're not already subscribed, what are you doing? Costs you nothing to do, helps the channel out. Just hit that little red button if you haven't yet. Anyways, we've all had the problem that we see here. We have some type like options, and when you hover over it, it just says options:options. That's not useful. You want to know what the actual type is of options. You can't see anything here. You can command click options and go look elsewhere, but that's not enough. You want to just know here, ideally. And look at what they gave us. Do you understand how revolutionary this is? I'll let y'all see my chat. They made effect usable. OMG, beautiful. Holy shit, this is what I needed. Oh, holy shit. Oh, God, yes. Damn, finally. Yeah. This is going to be a really good release. Also, I love they specify if you use an editor like VS Code. Slight shade thrown at Cursor, Windsurf, and Trey. Funny, though. This feature is currently in preview, and we're seeking feedback from both TypeScript and our partners on VS Code. For more details, see this PR for the feature. I just went out of my way to try and demo this feature because I'm really excited about it. And you can see here, it's not working, even though I'm in at the latest version of VS Code, and I turned on the setting. It should probably work if you're on VS Code Insiders, like the early access build or the beta build. But as you see here, even though it knows that this exists and should work, it doesn't appear to be working for me, sadly. So RIP for now, but know that this is coming soon, and hopefully right after it makes it to VS Code, all of the VS Code forks that we spend our times in will get this as well. I will certainly personally be annoying my friends over at Cursor to make sure that we get this in there ASAP. Configurable maximum hover length is the thing I missed till now, and this is actually really, it's again, small but super exciting. If you see what we were checking before with this demo, and we hover over 020 here, you see we get the full type definition until we hit a certain point, and then we get these truncated triple dots. And here, it's fine, but if we scroll a bit further, you'll see that it's not actually saving us anything, it's just killing information. Like, this is no easier to read because they're truncating. It's just annoying. So the ability to extend how long until they start truncating is really nice. There's a package that I recommend heavily that I absolutely adore. Pretty TypeScript errors. Sounds small and simple, but it's actually a life changer because it will parse these errors and handle all of the truncation and things TypeScript does and give you a much nicer format in your editor to see what actually is failing somewhere. This is unreadable slop. I'm not going to ever parse this mentally and figure out what it's supposed to say. Here, it's actually readable and gives me a good format. The extension is a pile of hacks to make it work because VS Code doesn't really give you the ability to render meaningful stuff inside of this view. So the reason that it's like too small and you have to manually expand it is actually because TypeScript and VS Code don't give you the exposure you need to do this the right way. So the solution and the workaround that this extension does is it renders this all as a SVG icon. So what we're getting here is an icon that is actually all of the content here. That's also why you can't like select the text in it because it's rendering as an icon as an SVG, which is so cool. The links here still work though, which is nice. You can get this link to the TypeScript error documentation, and you can get this link that will bring you to TS Error Translator, which is a project by our friend Matt Pocock to explain the error to you. Pretty cool. The reason I go through all of this is that it's important to have readable feedback in your editor. And while I appreciate the effort for truncation, it's a little too aggressive. And a lot of the work on this project is just trying to work around the aggressive truncation. If you can just bump up the max length on the hover, it'll get a lot better. You can also apparently disable it entirely, which is cool. Good stuff. So what else have we missed? We have the cache instantiation on mappers, which is the thing I talked about before, the performance improvements that I spent quite a bit of money to make happen. And then avoiding closure creation if file or directory exists using source. A function expression will typically allocate a new function object, even if the wrapper function is just passing through arguments to another function with no captured variable. In code pass around file existence checks, Vincent Bailey found examples of these pass-through function calls, even though the underlying function only took single arguments. This is a solution that's sped up type checks up to 11% for certain cases, for large projects in particular. Super cool. So what's next? Obviously, the native port of TypeScript, the Golang rewrite, will eventually be available as TypeScript version 7. You can check out the native port today by going to the TypeScript native previews, which are now available for you to install and use. They're released every night. They're still developing TypeScript 5.9 as well as addressing issues, and they encourage you to try it out and give feedback. It's actually one of the bigger concerns we had when these changes were proposed. We were scared the TypeScript team might be hesitant to make any meaningful change to how the type checking worked while they were in the middle of this massive overhaul and rewrite in Go. It sucks to have the target move underneath you while you're doing a big overhaul like that. So I was really pumped to see the TypeScript team still willing to consider and deeply review and eventually merge a change like this one while also doing that rewrite in parallel. It says a lot about the TypeScript team and how much they want to make sure the TypeScript language is serving us as users to the best of its ability. And I'm very thankful for the team for the work that they've done to help with all of this. This is a really cool and, in my opinion, quite underrated TypeScript release, and I hope you're as excited as I am. That's all I got for this one. Let me know what y'all think, and until next time, peace nerds.